Morning, sir. Good morning, sir. Dharmendra, sir.
Sir, good morning, sir. Good morning, sir.
Sir, now the time is 10 o'clock. So
Yes,
still participants are joining, sir.
right, sir. Right, sir.
This
No issue.
by 5, sir.
Okay, sir. We'll wait, sir.
Yes. Sir, still they are joining.
Okay, sir. Okay, sir.
Good morning, all. We, the Sheshadripuram Research Foundation, Sheshadripuram First Grade College, Department of Commerce and Management, and Indian Council for Cultural Relations and Karnataka Science and Technology Academy welcomes all the participants for the FDP on Social Science Research. Today is the fourth day, so we welcome all of you for the fourth day FDP session. First of all, I like to welcome today's resource person, Professor Dharmendra sir. Professor Dharmendra sir is basically from a teacher of commerce and management with an educational background of MCOM and MBA. Sir is very good in SPSS, AMOS, Smart PLS, Jamovi, and JAS softwares. And very best achievement of sir is very good in academics, and sir has cleared 7 times UGC net exam from the year of 2015 to 2019, and sir is also cleared Tamil Nadu SCT state eligibility test, and sir has served as a resource person for many workshops on data analysis in social science research. Sir was a coordinator for national level conferences and seminars also, and sir has delivered many guest lectures. Sir is very sincere, disciplined, organized, and the best quality of sir is very good hearted towards knowledge sharing. We welcome you, sir, on behalf of all the participants and on behalf of all the organizers. Welcome you, sir. Over to you, sir.
Thank you, sir. Good morning, all. Am I audible? Can anyone confirm I'm audible?
Yes, sir.
Right. Thank you. Sir, could you transfer me? Yeah, I got it. So, could anyone confirm, is my screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Thank you. Yeah. Before we proceed with the discussion, at the outset, I'd like to thank Sheshadripuram Education Trust, all the trustee members, and then management, the secretary, and then Dr. S.N. Venkatesh sir, the principal of Sheshadripuram First Grade Degree College, and then Dr. Vijay Kumar sir, the coordinator, PG Department of Commerce, and then my good friend, Dr. Ashwath Kumar sir, and then Professor Vasant Kumari madam, and all the participants for giving me an opportunity to talk, deliver a talk on SPSS. So today and tomorrow, we'll be discussing the foundation concept of data analysis. So I'm basically trying to start from the scratch. Let's say to what extent we can take this discussion, right? So today we'll be understanding the conceptual background of the various statistical applications, and then followed by various case studies. I've compiled hypothetical data set on each of the statistical tool, right from the descriptive statistics, inferential statistics, under that both parametric test as well as non-parametric test, right? So next 2 days, we'll be talking on all the basic statistical applications, such as the descriptive statistics parameters, followed by inferential statistics. In inferential statistics, all the parametric test as well as all the non-parametric test. The advanced statistical tools such as structural equation modeling, then binary logistic regression, then multi-dimensional scaling, correspondence analysis, discriminant analysis, and so on, will not be discussing in this 2 days session due to time constraint. If time permits, definitely we'll be very happy to discuss those concepts also, right? Okay. Before I proceed with the actual discussion, so let me share you my SPSS screen. I'm sure all of this data has been shared to your mail ID, the register mail ID. So you can, if you want, you can simultaneously practice along with me, so that if any queries are there, we can address then and there itself, right? So I've shared my SPSS screen here. So this is how the SPSS looks like. Of course, it looks similar to Excel, but it does not perform all the functions which are there in the spreadsheet. Please mind you, the statistical package for social science research is exclusively meant for analyzing the data, right? Only statistical applications we can apply in SPSS software, such as logical function, text function, financial functions, and or optimization solutions, optimization tools. All such functions cannot be performed in SPSS. And as we know, SPSS is a commercial software. So we have to, in order to use the software, we have to subscribe by paying certain amount. Of course, individual cannot offer this software, but what we can do is we can use this SPSS software, which is available in the ibm.com website, which is a free version, which is valid for 30 days, right? So after that, once again, we can uninstall and then reinstall the software. There are many software which are available to analyze the data. Just to quickly discuss some of the software. So we have two classification here. One is commercial software and then non-commercial software. There are certain software which we need to subscribe and then we use it. And there are certain software which are openly available. So anyone can access to such software. To name few commercial software, we have SPSS and then we have MOS, we have Smart PLS, and then we have Stata, and then we have StataCraft, and then we have so on. There are many softwares, etc. So many commercial softwares are there, and there are many non-commercial software, trust me, which competes equally to the commercial software, like SPSS, MOS, Smart PLS, and so on. To name few, we have Jamovi, which is an open source package of R, and then we have JASP, and then we have something called as Blue Sky, and then Blue Sky Statistics, and of course we have our software and so on. So these are the few non-commercial software. Today our discussion is only on SPSS. We'll be touching only on the SPSS, right? Statistical package for social science research. Statistical package for social science research. Just a second. Yeah, these are the few commercial software and these are the few non-commercial software. So we'll be focusing only on SPSS today, right? When we open SPSS application, these are the two pages which appears on the desktop. One is data view page, another one is variable view page. I'll just quickly discuss what is data view page and then what is variable view page. Then we'll proceed with the statistical application discussion, because understanding the characteristics of SPSS is very much required in order to apply any statistical tool. Please mind you, the basic foundation is very utmost important, right? So we have the data page. Data page typically comprises of number of rows and number of columns here. So we have an infinity row and infinity column here. You can enter as large as data as possible, both in rows and columns, right? So if you look at this data page, there are certain columns and there are certain rows here. Rows are mentioned as number 1, 2, 3, 4, and so on, whereas columns are mentioned as var, and so on. So this var is a short form of variable. Var is a short form of variable. Let's understand what is this row and what is this column. Why do we use this row and why do we use this column? In SPSS data page, row represent cases. What do you mean by cases? The individual responses or the individual respondent attributes. The individual respondent attributes. Let's consider have collected the request of the participant to mute themselves so that it will not cause disturbance to others. Thank you. Thank you. Right. So what does this row represent? Row represent cases. The technical term which is used to define the row is cases. Cases represent individual respondents. Means the individual attributes which are there in the questionnaire, we are going to enter row wise. Just to put it in simple terms, let's consider I have collected data from 10 respondents. Then where do I enter this 10 responses? In each row, I enter one response. So 10 respondent means 10 cases will appear, 10 rows will appear. Right? So in each row, I'm going to mention the data of the individual person or the individual respondents. Whereas column represents variable. So what do you mean by variable? The label of the variable means the description of the variable or the attributes of the variable. Right? So if I mention gender is a variable, the same thing will be appearing in the variable cell. So in SPSS data page, the simple rule is cases represent rows, whereas variable represents columns. Cases represents rows and variable represent columns. Okay. Come back to the variable view page. The most important aspect here. Before we enter any data, it is suggested, recommended to enter or to define the variable, right? To name the variable, then proceed with the data entry. So we have standard 11 columns here. So the first column is name, and then we have type, width, decimal, label, values, missing, columns, alignment, measurement, and then row. Just to quickly mention what is what. This name represents name of the variable, label of the variable. For example, as I mentioned, gender, if you consider as one variable, so gender I can enter in the first column, first cell of the name column, right? First cell of the name column. If I press, once I type the name of the variable and then press enter, the full description of the variable will be automatically taken. The characteristics of the variable will be automatically taken. Of course, we need to change certain aspects here. So once we define gender, please come back to the data view page. As I mentioned, so the first column in the data view page, I'm in the data view page. How do we switch between these two pages? By just pointing our mouse cursor to data view page and variable view page, we can switch between these two applications, two pages. So whatever the variable have defined in the variable page, the same thing will be appearing in column heading. So there in the variable page, I have defined gender. Can you see the first column heading now? Instead of var, it has taken gender. So now I can go on entering the gender of the respondents, 10 respondents. Similarly, if I define one more variable, let's consider educational qualification, and then press enter. The same thing will be appearing in column heading, second column heading, two variables defined, right? So the name column represents label of the variable, name of the variable, right? There are certain rules here. As far as name column is concerned, we need to follow certain conventions, right? Then only we can define the variable. So what are those conventions then? Convention number 1 says, this name column in the variable view page, the name column will accept only alphabetics. Please mind you, we cannot define numbers here. For example, if I define 1, 2, 3 and then press enter, it pop-ups an error message saying that variable contains illegal character. That means to say the name column can accept only alphabetics. The first rule of the name column, it will accept only alphabetics, right? The second rule is it will not accept any space. For example, if I mention serial space number, can you see here in between serial and number I've given one space. Will the software accept this kind of variable? No, definitely the software pop up the message variable contains illegal character. What was the illegal character over there? The illegal character is space. Each space is considered as one special character. Each space is considered as one special character. We cannot use space in the name cell. Not only here, wherever the name cell is there in the SPSS application, please mind you, it will not accept any space, right? The second convention of the name column, name variable will not accept any space, right? What next? The third rule says you cannot use any special character. What do you mean by special character? Such as star, division, plus, minus, comma, full stop, semicolon. You cannot use any special character in the name cell. Name column, you cannot use any special character. What happens if I use this? Again, it pops up the message, variable contains illegal character. So the third convention is do not use any special character in the name cell, right? Now the one question arises here. If I cannot use space and if I cannot use any special character, how do we differentiate between the words? For example, in the variable cell, there are two words. So consider educational qualification, right? So I'll just take off the second variable. So I want to define educational qualification. Can I use a running text here? No, it does not make sense actually. So what I can do is educational, instead of space, I can use one special character, which is underscore. The special character which is allowed in the name cell is an underscore symbol, underscore notation. So now I can type educational underscore qualification. Now the variable is defined, right? It will accept, right? So the fourth rule is you can use underscore in the name cell, right? The last rule, fifth rule of the name cell says you cannot use numbers, but you can use alphabetics. Can you use a combination of numbers and alphabetics? Of course, in a certain order, it will accept that also. For example, if I say 1, 2, 3, ABC, just an example, okay? Numbers followed by alphabetics, then the software will not accept. It says that variable contains illegal character. Okay, what character was number? That means to say you cannot proceed with them. You cannot start the variable name with the numbers. Numbers starting variable is not accepted. Then what is accepted? If I type ABC 1, 2, 3, alphabetics followed by numbers. Numbers followed by alphabetics is not allowed, whereas alphabetics followed by numbers is allowed. The software will accept. Right? The fifth rule of the name cell, numbers followed by alphabetics is not accepted in the name cell, whereas alphabetics followed by numbers is accepted in the name cell. So these are the basic conventions of the name cell, right? And then second type is numeric, right? This is nothing but type of the variable, right? So by default, if you define any variable in spaces, it takes numeric only, because whatever the data we feed in spaces, all the data will be expressed in numbers. It has to be only in numbers. Spaces can understand only numbers, please mind you. It cannot understand the alphabetics, right? So by default, the numeric is selected. Can we use some other option? Of course, we can use by selecting any cell. On the right hand side, there is a blue button. If you click on this blue button, we get various options, such as numeric, comma delimited, dot, and then scientific notation, date, currency, custom currency, and then string, and so on. There are different formats of variable type. Okay, depending on the context, we use a different context. For example, if you're defining any formula, then we may use scientific notation. For example, if the data is in date format, DDMMYY, then we can choose date format. Let's consider certain data is in certain country denomination, currency, like rupees, dollar, yen, right, and so on. Then we can use either dollar or custom currency, depending on the context. And then if the certain data is in what is called as alphabetics, which is string, for example, name of the respondent, name of the place, Bangalore, Mysore, Chennai, Tamil Nadu, and so on, right? So in that case, we may have to choose string option. But by and large, we'll be proceeding with numeric option, because all the data will be expressed in numbers. Then only we can analyze the data in the SPSS software. And nothing stops us using the other functions of the variable type. We can use depending on the context, right? Okay. This is the second characteristics of the variable view page. The third character is width. By default, it has taken 8 width. What do you mean by this 8 width? Means the number of string character which are allowed in a particular cell, right? The number of string character which are allowed in a particular data cell is maximum 8. You cannot use more than 8 in a particular cell of a data page. So that is what this width represents. And please mind you, it is a string character, not the number, right? So you can use up to 8 character. Can we increase or decrease the same? Yes. if you bring your mouse point here on the right hand side of the cell, there is an up arrow mark and down arrow mark here. By choosing this up arrow mark, we can increase the width of the string character. By choosing the down arrow mark, we can decrease the width of the string character. Right. So this widths represent number of string characters which are allowed in a particular data set. Okay. Then the next one is decimal. What is this decimal? After point, how many digits do we want? Whether we want 2 decimals or we want 3 decimals, 4 decimals, and so on. You can increase or decrease the same by choosing this up arrow mark and down arrow mark. Now for gender, 3 decimal is selected. For example, if I type 1, 2, and so on, 1, 2, can you see here? After point, there are 2 decimals, 3 decimals here. After point, there are 3 decimals. So if you decrease it to 0, then the same thing will be reflected in the data view page. Now there is no decimal because decimal is chosen as 0, right? And then label. So what does this label represents? This label represents full description of the variable. Then when we already have this name column, why should we define the variable full name again? As I told you, there are certain restrictions here. Can you see here? I cannot use the space in between the 2 terms of the variable. Correct now, educational underscore qualification. If the same thing is reflected in the data analysis, then it may not look good, right? So what we do here, we use the full description of the variable as it is. For example, I can use gender of the respondents, and then I can use educational space qualification of the respondents, right? And so on. And whatever we define in the label cell, please find out the same thing will be reflected in the output. For example, if I generate frequency table for this gender, so at the beginning of the table, it will be shown as gender of the respondent, so that you need not to type the table name once again, right? So whatever the label we define here, the same thing will be reflected in description of the output. Then we have something called as values. I'll come to this values little while from now. And then we have something called as missing frequency. So missing frequency, if the data set contains missing frequency, we can use the same. There is another option to use a missing frequency analysis in the transform button. So if you click on this transform icon, there is something called as replace missing values. So both the functions perform the same application, finding the missing frequencies and imputing missing frequencies, certain values. Then we have a column as 8. What is this column 8? The width of the column. So as of now, default width it has taken is 8. So just to make you understand, let me increase this first column width, that is variable number 1 width, to 14. Then come back to the data view page. Can you see here? The width of the first column is larger than the width of this other columns, because the width of the other column is only 8. The width of the first column we have increased to 14. So what is this width of column width represents here? The space of the width. Please mind you, here width stands for the number of string characters allowed in a particular data set, whereas column width represents the space of the width. Okay, so by default 8 column width will be selected. That's more than sufficient, right? So let the data be any digits, like 7 digits, 8 digits, and so on. Then we have alignment. So what does this alignment stand for? So we have got 3 alignments here: left alignment, right alignment, and then center alignment. Just a second. Yeah. Okay. So we have left alignment, right alignment, and then center alignment. So this this function particularly denotes the alignment of the data. For example, if I choose left alignment, come back to the data view page. Can you see here? Whatever the data I have entered in the first column, gender column, the same data is appeared on the left hand side of the cell. If I choose right alignment, then the same data will be appearing on the right hand side of the cell. Can you see the difference now? Previously it was on left hand side of the cell. Now the same thing is come back to the right hand side of the cell. Then if you choose center alignment, then the data will be appearing in the center of the cell. The data will be appearing in the center of the cell. So this alignment stands for the alignment of the data in a particular cell. Then we have measurement. So what is this measurement? We have this three measurement. The most important aspect here, I want you to give your attention here. Scale, ordinal, nominal, right? Scale, ordinal, nominal. So we'll just discuss this when we choose a statistical application. Normally in scaling type, we have four types of scaling: nominal scaling, ordinal scaling, interval scaling, and then ratio scaling. But here we have only these three types of measurement: nominal, ordinal, and scale. Let's see what is nominal, what is ordinal, what is scale when we discuss a statistical application. And the last thing is roll column. So this roll column basically contains few functions such as input, target, both, none, partition, and then split, right? Whatever the data we feed in the spaces basically acts as an input. The software will process it and it will give us the output, right? So by default, the role what we select is input. In certain cases, multinomial regression and so on cases, there are in certain cells, we may use this target option or both option, both input and target option, right? Depending on the context. But in all other cases, the role, the data what we feed will act as an input. The software will process and then it will give the output, right? So these are the basic characteristics of the spaces. So if you have this conceptual background, I'm sure certain minute aspect we can able to address easily in the spaces application. And then if you look at this spaces software, the very first heading is called as, or the very first section is called as the status bar or the title bar. So this particular region is called as title bar. The file name will be reflected here. Then we have something called as menu bar, such as file, edit, view, data, transform, analyze, graphs, and so on. So this particular section is called as menu bar. And the third section is called as ribbon section. The third section is called as a ribbon section. So basically, in order to employ certain statistical functions, we use this ribbon function, such as to find and replace certain data, and then to select certain data, and then value to label, label to value certain data, and so on, right? And then we have left out one more column, which is value column. So what is this value column denotes here? Okay. So when we select the measurement type, it calls for defining certain values, especially when you have the nominal scaling, ordinal scaling, and then interval scaling. When we have nominal, ordinal, interval scaling, it calls for defining the label of such variable, because all these three scaling, nominal, ordinal, interval, possess a basic character which is such as label. So whenever we have label data, the same label has to be defined in the value label. For example, gender. So in gender, we have got two labels, male and female. So we can define what is male, what is female. Like value 1 is equal to male, and then click on this add button. Value 2 is equal to female. Click on this add button, right? So or vice versa. Female can be coded as 1, male can be coded as 2. So click OK button. Once we define the value, click OK button. Come back to the data view page. Now, if you look at the very first column, gender 1 to 1 to is selected, right? In the ribbon section, there is something called as value to label button, label to value button. Now the data is in values like 1 to 1 to and so on. If I want to convert into labels, I can click on this button. Can you see here? Male, female, male, female. So 1 is coded as male, 2 is coded as female. 1 is coded as male, 2 is coded as female, right? So we can switch between qualitative to quantitative, quantitative to qualitative. Label to value, value to labels. Okay. So this is the foundation concept of SPSS. I'm sure a lot more goes into this, but from our subsequent discussion, I think this is more than sufficient. Right. Now let's come back to the data analysis discussion. So I'll just take you through an Excel application. Okay. So data analysis and reporting. Data analysis and reporting. Data analysis and reporting. Once we collect the data, once we feed the data in SPSS, then we have to analyze the data. We have to analyze the data in order to draw certain conclusions with respect to a stated phenomenon. How do we analyze the data? So there are two approaches as far as data analysis is concerned. The first one is called as descriptive statistics. Descriptive statistics. I'll just put it as short form, descriptive stats. And then the second approach is called as inferential statistics. Inferential stats. So in order to analyze the data, basically we use these two approaches. Either we can use descriptive statistics or inferential statistics. What happens in case of descriptive statistics? Okay, what is basically descriptive statistics? Any statistics which describes the pattern of the data, such as it could be mean value or the median value or more, or deviation from the arithmetic mean, standard deviation, the minimum value and the maximum value, range value, and of course distribution of the data, such as skewness, kurtosis, and so on. Right? Any statistics which basically describes the pattern of the data can be termed as descriptive statistics. If a statistical tool is describing just the pattern of the data, then it is termed as descriptive. Statistics which describes the data, describes the characteristics of the data, is called as descriptive statistics. To name few, we have mean, median, mode, and then standard deviation, and then range, and of course variance. Sorry, var stand for variance, and then we have quartile deviation, and then we have skewness, and then we have kurtosis. Right? Here, in this context, we'll be restricting our discussion to only mean as well as standard deviation. In certain cases, quartile deviation. Okay, and of course, I'm sure all the other descriptive statistics you're more familiar. So we'll be discussing the important descriptive statistics such as mean, standard deviation, and quartile deviation. Right. When it comes to the inferential statistics, basically we test the hypothesis. Right. In inferential statistics, we focus on testing the hypothesis. Right. So SIS is a singular form of hypothesis. SES is a plural form of hypothesis. Inferential statistics basically infers the data, means we draw certain conclusion with a stated phenomenon. In simple terms, we test the hypothesis by employing inferential statistics. How to test the hypothesis by employing inferential statistics? Again, here there are two approaches. One is we can use parametric statistical tools. I'll just put it as parametric tools. Another one is non-parametric tools. Non-parametric tools. Right? So this is how we analyze the data. So either by employing descriptive statistics or inferential statistics. So in descriptive statistics, basically we describe the pattern of the data, characteristics of the data. Whereas in inferential statistics, we test the hypothesis either by employing parametric tools and non-parametric tools. We'll discuss in a short file what are the various parametric tools and non-parametric tools. Okay. Now the big question is, on what basis, on what grounds do we choose between parametric tools and non-parametric tools? I'm sure descriptive statistics is not our worry. So we know how to interpret mean, standard deviation, and so on. How do we choose between parametric tools and non-parametric tools? That's the most important, crucial aspect in the application of statistics. On what grounds do we select between these two tools, parametric and non-parametric tools? There are many criteria. This might be not single criteria. There are many criteria which drives us in selecting between parametric application and non-parametric application. Let's identify such drivers, the factors which affects the selection of the statistical tool, right? So let me put it here, factors affecting selection of the statistical tool. So when I say statistical tool, what does it mean? Parametric statistical tool and non-parametric statistical tool. What are the various factors which influences the selection of parametric tools and the selection of non-parametric tools? Okay. Or in simple terms, what are the various factors which drives us in selection of certain statistical tool? There are many factors which influence the selection of statistical tool. To name few, the first one, nature of the variable. So the statistical tool must be supported by the nature of the variable. And then the second factor which influences the selection of the statistical tool is the purpose of the analysis. And then the third driver which influences the selection of the statistical tool is what is called as the distribution of the data. Right? The third factor which influences the selection of the statistical tool is the distribution of the data. And the last factor is sample size. On this, of course, there could be many other factors, but these are the what is called as largely used, by and large used factors in order to select certain statistical application. Nature of the variable, purpose of the analysis, distribution of the data, sample size. Among this, probably I would say distribution of the data plays a crucial role in selection of the statistical tool, right? So based on the distribution of the data, we choose between parametric and non-parametric. But even, of course, we can use other factors also. Let's quickly discuss what is this nature of the variable, how does this influences our statistical tool, selection of the statistical tool, right? So let us discuss how the nature of the variable influences the selection of the statistical tool. I'm sure all of us are familiar with different types of data. Any idea what are the different types of data? You can put it in the chat box or unmute yourself. So what are the different types of data, sir, madam? Okay, I think unmute option is not available. So what are the various types of data normally we come across in the data analysis? Okay, somebody said primary data and secondary data. Okay, primary data and secondary data. Right. What else, sir? Okay, again the same answer, primary data, secondary data. And then what do you mean by types of data sources then? If this is types of data, primary data and secondary data, if these are all called as types of data, then what is types of data sources? Okay. Somebody said continuous data, group data, ungroup data, quantitative, qualitative. Perfect. All this are correct. Right. So when it comes to the types of data sources, please note, we have two types of data sources, primary data sources and secondary data sources, right? So data type sources are primary and secondary. When it comes to the types of data, so we have three types of data here. One is called as cross-sectional data. Cross-sectional data. The first type of data is cross-sectional data. The second type of data is called as time series data, which is also called as longitudinal data. The third type of data is called as panel data, right? So when it comes to the types of data, so we have got these three categories: cross-sectional data, time series data, and then panel data. Types of data sources are primary data and secondary data. Of course, we do have other classifications such as quantitative data, qualitative data, and so on. All that is correct. Nothing wrong in that. But types of data generally refer to cross-sectional data, time series data, panel data. Just to quickly discuss, what is cross-sectional data? A data which is collected across different sections of the society at a particular point in time is called as cross-sectional data. So a data which is collected across the different segments of the society at a particular point in time is called as cross-sectional data. Consider, today I'm doing a marketing research, customer satisfaction towards Patanjali products. I prepare a questionnaire, which is a research instrument. I give it to the customer, ask their responses, and I make a note of the same. So it becomes what? The cross-sectional data. So I'm collecting data from a particular section of the society. Who is that particular section? The customers of Patanjali product, right? So which is called as cross-sectional data. What is time series data or panel data then? A data which is collected over the period of time across the different sections of the society, right? Or let me put it this way, in a simple terms, a data which is collected over the period of time can be termed as time series data. Just to give one small example, consider we are doing the profitability analysis of the Navratna companies in India, right? The Navratna companies in India. What do we do? How do we analyze the profitability? We take the various profitability parameters and then we go for analysis. Where do we extract this profitability parameters? From the annual reports of such companies, right? Consider from 2010 to 2020, we collect the various profitability parameters, right? Data which is collected over the period of time from 2010 to 2020. This is not collected at a particular point in time. So this data will be collected over a period of time. Such data, it can be termed as time series data. Of course, some says cross-sectional data is the primary data, whereas time series data is secondary data. You can define that way also. Nothing wrong in that. And then Panel data. So what is panel data? Panel data is a combination of cross-sectional data and time series data. Consider I'm doing a survey on or research on mergers and acquisitions. So I'll be analyzing the profitability, and also I'll be studying the employee perception towards mergers and acquisitions. So to analyze the profitability, I collect the data from 2010 to 2020. Just an example from the annual report of such companies, right? That becomes a time series data. So when I prepare questionnaire to get the perception of the employees with respect to mergers and acquisition, that becomes a cross-sectional data. So if I'm using this combination, then it is termed as panel data. Okay. So these are the different types of data sources and then different types of data. Now, the correct tourist arrival from 2000 onwards is a classic example for time series data. Perfect. Thank you, sir. Then we have types of scaling. This is the most crucial part here. Types of scaling or types of scale. So when it comes to the types of scale, so we have got this 4 types of scale: nominal, ordinal, and then interval, ratio. I'm sure all of us know what is what. I'll just quickly describe the characteristics of this types of scaling, and then we'll proceed with the subsequent discussion. So what is nominal scaling? It's a type of scaling in which the data will be labeled, right? The data represent different categories, or the data represent different attributes of the variable. Okay, so the basic characteristics of the nominal scaling is data possess label character, means attribute character. So the example for this nominal variable is gender. So in gender, we have got 2 labels, male and female, correct now? And no label is inferior, no label is superior. All the labels will be having equal weightage, right? And this will not have any statistical inference because these are labels. That's why it's called as nominal. A data which processes the label character can be termed as nominal scaling. What do you mean by ordinal scaling? An extension of nominal scaling can be termed as ordinal scaling, in which the data possesses label character as well as certain order. That means to say, so ordinal scaling is a type of scaling in which the data will be labeled, and this label will have a certain order. For example, the classic example for ordinal scaling is educational qualification. So in educational qualification, we may give SSLC and then PUC and then graduation, post-graduation, and then professional and so on. Please note, these are all labels: SLC, PUC, graduation, post-graduation, and so on. These are all labels. These labels have certain order. This has to be the same order, like SSLC, PUC, and then graduation, post-graduation, right? Can we interchange this order, like PUC, then post-graduation, then graduation, then SSLC? It does not make sense, and it is not permitted, right? So therefore, this is called as an ordinal data. Ordinal data or ordinal scaling technique basically possesses 2 characters, label and the order. The next one is interval, the most regularly used type of scaling, especially in the social science research. Interval scaling is a type of scaling in which the data is labeled and the data will have certain order. This order will have even differences. And no absolute zero, right? So if the data contains, if the scaling type contains label, and if this label is in certain order, and if this order has even differences, right, then just a second. If this, so if this differences, if this order contains even differences between the order, if there is even differences, then it can be termed as interval, and there will be no absolute zero here, right? So classic example for this interval scaling, I'll just put it as Likert scale statements. So the example is Likert scaling, any Likert scale statement. So how do we code the data here? Like strongly disagree, and then followed by disagree, followed by neutral, and then agree, strongly agree, right? So this is how we code the data as far as Likert scale is concerned. So what does it mean? Strongly disagree, neutral, agree, strongly agree. These are all labels, the first character. And this label has certain order. It has to be in the same order, like strongly disagree,
Sir,
disagree.
your voice is not audible, sir.
No, ma'am, it's audible actually. Maybe you have some network issues, ma'am.
Other participant delegates can confirm I'm audible?
Yes, sir, it's audible.
Yes, sir. Yes, sir. Yes.
Thank you.
You are audible, sir. You are audible.
Thank you, sir. Right. So we have Likert scale. It's a classic example for this interval scaling. Here, the data is labeled. This label has certain order, like strongly agree, strongly disagree, disagree, neutral, agree, strongly agree. For a negative Likert scale statement, we inverse this order. Instead of from strongly disagree, we start from strongly agree. Or we change the coding pattern. That's it, right? So here, the data is labeled. The data is having certain order, right? This order has even differences. What do you mean by even differences? All of you, please look at the screen. Whatever the difference exists between strongly disagree and disagree, the same difference exists between neutral to strongly agree. And whatever the difference exists between disagree to neutral, the same difference exists between neutral to strongly agree. Whatever the difference exists between neutral to agree, the same difference exists between agree to strongly agree. Agree to strongly agree. Just to put it in numbers, if you code in this pattern, strongly disagree as 1, disagree 2, neutral 3, agree 4, strongly agree 5, right? Okay. Look at the definition now. This is labels. This label has certain orders. There is an even differences between the order. So what is the difference between 2 and 1? The difference between 2 and 1 is 1. What is the difference between 3 and 2? It is 1. What is the difference between 4 and 3? It is 1. So what is the difference between 5 and 4? The difference is 1. Correct. So this differences is even. Even differences are there, right? So what is this called as? The interval scaling. Of course, there is a debate. Okay, should we consider this Likert scale statement as an ordinal data or ordinal scaling or interval scaling? Many literature, supporting literature available, many statistician agrees that this Likert scale is a ordinal scaling because it possesses even ordinal characters also, ordinal scaling characteristics. And many statistician says that the Likert scale statement can be considered as interval also. There are certain literature support, the sufficient literature support. So I want you to look at this literature support because there's a normal question when I go to any workshop. Likert scale should be considered as an ordinal scaling. Definitely not. So in social science research, measuring a variable itself is difficult. The only way which we use in order to measure the variable is Likert scale. Because measuring attributes is very difficult. We cannot use like open-ended questions or dichotomous questions in order to measure the variable. The only and the widely used technique is Likert scale statement. If you consider this Likert scale statement as an ordinal scaling technique, whatever the statistical application we choose, that will go definitely wrong, right? So please mind you, Likert scale is an interval scaling. So that's one clarification and just wanted to state now itself. Thank you. Right. Then the last form of scaling is ratio scaling. So of course, this ratio scaling poses all the characters such as label, order, differences, and absolute zero. In very simple terms, I say ratio scaling is a type of scaling technique in which the data is expressed in absolute numbers and there'll be absolute zero also. Okay, so the classic example for this ratio scaling, I ask the respondent, what is your income? What is your income? And I don't give any option like 0 to 2,50,000, 2,50,000 to 5 lakh. I don't give any options, right? Where the respondent will fill is actual income, his or her actual income. For example, 2,58,000 per annum, right? And then 5,68,000 per annum. And then 1,25,000 per annum, 11,54,000 per annum, and so on. So what is this data called as? This data is called as the ratio data. If the data is expressed in absolute numbers, the same can be termed as ratio data, right? Having understood the characteristics of the different types of scaling, if I ask you which is the most accurate form of data or which is the most accurate form of scaling technique, probably everyone will agree, right? The ratio data is the most accurate form of data. But to measure variable in social science research, we cannot use this ratio. So we go with Likert scale or any other rating techniques. Okay. So this is a brief description. How does this nature of the variable influences the selection of the statistical tool? That is what we are discussing here. Let me give 3 scenarios here, like scenario 1, scenario 2, scenario 3. So consider we test hypothesis for 2 variables. Of course, more than 2 variables also we can test. Okay. So look at this now. When we have, okay, these are the 3 scenarios. So let me draw a table here. Please bear with me. I'll be starting the practical application only of this conceptual background discussion, right? So otherwise the practical application may not sound good, right? Okay. So when we have these 4 types of scaling, just for the application of the statistical tool, let's classify this 4 types of scaling into 2 broad categories. Nominal scaling and ordinal scaling is called as categorical data. Nominal scaling, the combination of nominal and ordinal, is called as categorical data, or it is also called as qualitative data. Qualitative data. So the combination of nominal, ordinal is called as categorical or qualitative data. Okay. So the combination of nominal, ordinal. The combination of interval and ratio is called as metric data, or it is also called as quantitative data, or it is also called as scale data. It is also called as scale data. Right. So the combination of nominal, ordinal is called as categorical data or qualitative data, whereas the combination of interval and ratio is called as the scale data or quantitative data or metric data. This classification is very important from our subsequent discussion point of view. Let's understand the situation now. Let's consider there are 3 situations. So we always test hypothesis for 2 variables. V1, V2 stand for variable 1 and variable 2. So under situation 1, let's consider variable 1 is categorical. Variable 2 is also categorical. Then what is the statistical tool which calls for employing in order to analyze the data? If you're testing the hypothesis, then we can apply chi-square test when you have got 2 categorical variables. Please mind you. So only we can apply chi-square when we have the nature of the variable as categorical. And we know what is categorical, right? So the categorical is a combination of nominal and ordinal. Combination of nominal and ordinal is called as categorical data. Fine. Let's consider the second situation. Consider variable 1 is metric, M stand for metric. Variable 2 is also metric. Then what kind of statistical tool do we employ? Either we apply correlation analysis or regression analysis. So when we have got both the variables as metric, variable 1 is also metric, variable 2 is also a metric, then what is the statistical tool do we employ? Either correlation or regression concept. Either correlation or regression. In which context do we use correlation? In which context we use regression? In the next factor we'll discuss the purpose of the analysis. Consider the next situation. The next situation is when we have one metric variable and another categorical variable. So what kind of statistical tool do we employ? We employ t-test family. So I'm just mentioning the term family because there are broad techniques available under t-test, or Anova family. When we have got one categorical variable, one metric variable, then we are going to use either t-test or Anova family. So we understood what is categorical. The combination of nominal, ordinal is called as categorical, whereas the combination of interval and ratio is called as metric. When 2 variables are categorical, apply chi-square analysis. We'll see why to apply chi-square analysis. And then when 2 variables are metric, apply either correlation or regression. When one variable is metric, another variable is categorical, apply t-test family or Anova family. So what are the t-test family techniques, Anova family techniques? We'll discuss. This is how the nature of the variable influences the selection of the statistical tool, right? Okay, let's quickly take up the second concept, purpose of the analysis. It's not merely the nature of the analysis which helps us in employing certain statistical tool. Even we have to check why we have to perform certain statistical tools here, right? So let's understand the second factor which drives us in selection of the statistical tool. So the purpose could be, we can compare the proportions between categorical variable, 2 or more categorical variable. So the first purpose is when you're comparing the percentage, the proportions between 2 categorical variable. So if male is this many percentage, female is this many percentage. So what is the corresponding percentage in savings, right? So 50,000 savings, 60,000 savings. This percentage proportions, if you're analyzing, then we have to, let's say, which statistical tool do we employ there? Okay, so we'll see that. The second purpose could be to compare mean differences, between metric variable. Very important. Okay, so if you're comparing the categorical variable, then we compare the proportions. We cannot compare the mean. When you're comparing the metric variable, then definitely we have to compare the mean. Okay, what statistical tool do we employ? We'll just discuss now in a short while. And the third purpose could be to check the relationship between two metric variables, two or more metric variables. Okay, what kind of statistical tool do we employ? We'll discuss now. And the last purpose could be to estimate one variable with another variable. To estimate one variable with the help of another variable. So the fourth purpose could be predict one variable with the help of another variable. So these are the four purposes of analysis. Please mind you, any statistical tool we employ, right? Either it could be a basic statistical tool or advanced statistical tool. It falls under the broad range of these four categories. Either we may compare the proportions, or we may compare the mean differences, or we may compare the relationship, or we may predict one variable with the help of another variable. So the last one is the most important one and widely used technique, the regression model, because all the advanced statistical parameters are built based on the regression model, right? So this is how the third purpose influences the selection of the statistical tool. Okay, and then the next factor is distribution of the data. How the distribution of the data helps us in selection of the statistical tool. Check whether the data is normally distributed or distribution free, non-normally distributed, right? Check whether the data is normally distributed or distribution free. If the data is normally distributed, then we employ parametric test. Of course, other assumptions are there, we'll discuss then and there itself. When the data is distribution free, we employ non-parametric statistical tool. So parametric tests are the most powerful one compared to the non-parametric tools. So as discussed by the yesterday resource person, Professor Matthew sir, right? Then we have the last factor, which is the sample size. So when we have the small sample size, then we may employ this non-parametric statistical tool. When we have this large sample size, then it calls for employing parametric statistical tools. Now the question is, how do we quantify the small sample size and the large sample size? This is a large, widely used context. Whenever the sample size is less than 30, we consider it as small sample. If the sample size is more than 30, we employ the parametric tools, and we consider it to be large sample size, right? Okay. Now we have discussed these 4 points. Let's bring all these 4 factors in a single table, and then we'll proceed with the practical applications. Okay. Right. Let me tabulate this now. Choosing between parametric and non-parametric. Choosing between parametric and non-parametric. So let me tabulate the information. The first one is nature of the variable, and then parametric statistical tool. So just copy this and then paste it here. And then non-parametric test, and also we'll discuss the purpose. Okay. So under that, let's take the very first purpose, or I'll just put it. I'll put it this way only. Right. So the very first purpose is to compare the proportions. Just copy here. To compare between the proportions of categorical variable. So what kind of statistical tool do we employ? right? So whenever we have got 2 or greater than 2 categorical variable, when we have got 2 or more than categorical variable, cat variable stands for categorical variable. As far as parametric test is concerned, we employ something called as frequency analysis. As far as non-parametric application is concerned, we employ chi-square test. Chi-square test. The purpose of chi-square test could be to check the association between two variables or to check the dependency of one variable on the other variable. So I'll call it as chi-square as independent test, right? So dependency of one variable on the other variable, or it could be goodness of fit test. The purpose could be to check the goodness of fit, right? So I'll repeat, when we have to compare the proportionate between categorical variables. So in case of parametric application, we use something called as frequency analysis, percentage analysis. If it is a non-parametric application, then we may choose chi-square test. Why do we employ chi-square? Or chi-square serves what? It serves to check the association between two variables, or the test of independence between two variables, or goodness of fit between the categorical variables, right? So this is the very first application of the statistical tool. Okay. Having understood the first one, let's go to the second case. So what is the second one? To compare the mean differences between the metric variable. To compare mean differences between the metric variable. Okay. So here, which statistical tool do we employ? Both t-test family and also ANOVA family. ANOVA family. So this is the most important part here. Let's give concentration here. So let me take the first category. First one is when we have one metric variable with known population mean, right? So when we have got one metric variable with known population mean, then the parametric twist which we are going to employ is called as one sample t-test. One sample t-test. When we have one metric variable with known population mean, so we may employ one sample t-test as far as parametric application. In case of non-parametric application, we'll be employing something called as Wilcoxon sign test. Wilcoxon sign test. So what is the purpose of one sample t-test or Wilcoxon sign test? Both the statistical tools serve the same purpose. What is that purpose? We can compare sample mean with the population mean. Sample mean can be compared with the population mean. In case of Wilcoxon sign test, sample median can be compared with population median. Sample median can be compared with population median. So why it's a median? We'll see it down, right? Okay. Now the big question is when to employ this one sample t-test, when to employ this Wilcoxon sign test. When do we employ the one sample t-test? When do we employ Wilcoxon sign test? For that, the basic assumption has to be satisfied by the parametric tools. If the data is, let me call it as normality here. Normality. If the data satisfies the normality assumption, please employ one sample t-test. If the data is distribution free, if the normality assumption is not satisfied, then employ Wilcoxon sign test, right? So on what basis do we choose between these two categories? When the data is normally distributed, employ one sample t-test. When the data is distribution free, employ Wilcoxon sign test. So when the normality assumption is not satisfied, employ Wilcoxon sign test. So this is the first application of the t-test family, right? Let's go to the next one, right? The second application. Let's consider we have got two metric variable. Okay, I'm sorry, let me put it this way. One metric variable with one categorical variable in bracket two categories or two labels. when we have one metric variable and one categorical variable, if this categorical variable is having only two labels, then as far as parametric tool is concerned, we employ something called as independent sample t-test, independent sample t-test, or it's also called as two sample t-test. It's also called as two sample t-test. If it is non-parametric application, we employ something called as Mann-Whitney U-test, Mann-Whitney U-test, or it could be Welch test also. Welch test. Okay. So what is this Mann-Whitney U-test, Welch test? All that we'll be discussing now. Right. So when we have parametric application, in case of one metric variable and one categorical variable, if the categorical variable is having only two labels, gender, male and female are the two labels, employ parametric tools. If it is a non-parametric application, then employ Mann-Whitney U-test or Welch test. So what is the purpose of independent sample t-test or Mann-Whitney U independent sample t-test? Both serve the same purpose. We can check the mean differences in the metric variable, across two different groups. So what we can do, we can check the mean differences in the metric variable across two different categories or two different groups. Now the question is when to employ independent sample t-test and when to employ Mann-Whitney U-test or Welch test. Here we have got two assumptions. One is normality assumption and the second one is homogeneity assumption, or it's also called as variances, equal variances assumed. Okay. So whenever the data satisfies normality assumption, let's consider the data satisfies normality assumption, then employ independent sample t-test. Again, along with the normality, homogeneity assumption is satisfied. If normality and homogeneity both are satisfied, employ independent sample t-test. Okay. In case of, consider normality assumption is satisfied, but homogeneity assumption is not satisfied. When the data satisfied normality assumption, but homogeneity assumption is not satisfied, equal variance is not assumed, then what is the corresponding non-parametric tool we are going to employ? Welch test. So we may employ Welch test in order to analyze such data. I'm just indicating the same color. I repeat, when the normality assumption is satisfied, homogeneity is not satisfied, employ Welch test, which is a non-parametric. Consider the other one. If the normality assumption is not satisfied and homogeneity assumption is satisfied. So I'll just highlight with this different color. If the normality assumption is not satisfied, just a second, and homogeneity assumption is satisfied, then employ what is called as Mann-Whitney U-test. So in that particular case, we have to employ Mann-Whitney U independent sample t-test, non-parametric test. I repeat, so when both assumptions are satisfied, employ independent sample t-test. If normality assumption satisfied, homogeneity not satisfied, employ Welch test. If normality not satisfied, homogeneity assumption satisfied, employ Mann-Whitney U-test. This is as far as independent sample t-test is concerned. And please mind you, we are in comparing the mean differences between the metric variable. So in all these cases, we are checking the mean differences. Right. Consider the next case. So what is the next case? Consider we have got two metric variables. From the same group. And we know what is same group. So what do you mean by same group? From the same set of respondent, we will have to collect the data. When you have got two metric variable, and if the data is collected from the same group, if the data is collected from different groups, then it's independent sample t-test. If the data is collected from the same group on a similar variable, then we have to employ paired sample t-test. As far as parametric application is concerned, paired sample t-test. Right. And then as far as non-parametric application is concerned, we have to employ something called as Wilcoxon paired sample t-test. Wilcoxon paid sample t-test. Now the question is, why do we employ this paid sample t-test or Wilcoxon paid sample t-test? Why do we employ a paid sample t-test or Wilcoxon paid sample t-test? So here also the purpose is same, to compare the mean differences in the metric variable across the same group of the people. So in case of independent sample, it is two different groups. Here, the same group across the same group or same set of people. When do we employ this paid sample t-test and when to employ this Wilcoxon sign test? The assumption is normality. So if the normality assumption is satisfied, employ paid sample t-test. If the normality assumption is not satisfied, employ Wilcoxon paid sample t-test. Okay. On this particular ground, we are ending with t-test family. In t-test family, we have discussed one sample t-test, independent sample t-test, as well as paid sample t-test. Let's move on to the next case. What is the next case? We'll take up the ANOVA family. Consider we have got one metric variable and one categorical variable, and we know what is metric and what is categorical variable now. And this categorical variable, if it has more than two labels, in the last category, what we had, independent sample t-test, we had only two labels like gender, male and female. In case of ANOVA, we'll be having more than two labels: education qualification, SSLC, PUC, graduation, post-graduation, and above. So this is a classic example for categorical variable with more than two labels. In case of parametric application, we'll be employing something called as one-way ANOVA. I'll just put it as ANOVA. And then in case of non-parametric application, we'll be employing Kruskal-Wallis ANOVA. Kruskal-Wallis ANOVA. Right? So here, the same rule. As far as ANOVA is concerned, normality assumption and homogeneity assumption, both the condition must be satisfied. So if normality assumption is not satisfied, homogeneity assumption satisfied or not satisfied, it's immaterial, right? Then we can employ Kruskal-Wallis ANOVA. So when both assumptions are satisfied, normality, homogeneity, employ ANOVA. If normality assumption satisfied, homogeneity assumption satisfied, normality not satisfied, or homogeneity also not satisfied, then we have to employ something called as Kruskal-Wallis ANOVA. So what is the purpose of this ANOVA or Kruskal-Wallis ANOVA? Right? The purpose is same, to check the mean differences, to compare the mean differences in the metric variable across more than two groups, it's independent sample t-test. More than two groups, it is either ANOVA or Kruskal-Wallis ANOVA. Yeah. Just a second. So this is what is called as the ANOVA family. In case of two-way ANOVA, we'll be playing parametric application two-way ANOVA, and then non-parametric application, the Friedman repeated measure ANOVA, and so on. Okay, I'll just show another one. Let me copy this one metric variable and two or more categorical variable with more than two labels. We'll be applying two-way ANOVA here, and we'll be applying Friedman repeated measure ANOVA. So the purpose is same, to check the mean differences in metric variable across more than two different groups of the independent variable. The independent variables. Okay. So here also the assumption is same. When normality, homogeneity, both assumptions are satisfied, two-way ANOVA. If normality not satisfied, homogeneity may be satisfied or may not be satisfied, Friedman repeated measures ANOVA. So this is called as the ANOVA family. Okay. Let us take the next purpose. The next purpose of the statistical tool is to compare or to check the relationship between metric variable. When we have to check the relationship between metric variable, what is the statistical tool do we employ? When we have got two or more than two metric variable. In case of ANOVA parametric tool, we'll be employing Pearson correlation. In case of non-parametric tool, we'll be employing Spearman rank correlation. Spearman rank correlation. The purpose of this analysis is to check the relationship between two metric variables. Oh. So the assumption is same. When the normality assumption is satisfied, apply Pearson correlation. If the normality assumption is not satisfied, apply Spearman rank correlation. So we are done with correlation analysis now. Let's take the last model, the prediction model. When we have to estimate one variable with the help of another variable. When we have to estimate one variable with the help of another variable. And the nature of the variable, when we have two or more than two. In case of parametric tool, we'll be employing regression model. In case of non-parametric tool, we'll be employing non-parametric regression. Non-parametric regression. So what is the purpose of regression model or non-parametric regression model? Basically, to estimate one variable. So regression model is employed to estimate one variable with another variable. So this is why we employ the regression model, and the assumptions are normality as well as linearity. So in case of regression model, parametric application, normality assumption has to be satisfied, linearity assumption has to be satisfied, right? In case of non-parametric tool, normality assumption not satisfied, linearity may be satisfied or may not be satisfied. Okay, so this is why we employ what is called as the regression model. Okay, so on this particular background, right, with this particular discussion, I'll be starting with descriptive statistics, right? Okay, so this is how the various factors influences the selection of the statistical tool. By and large, I have listed out all the basic statistical application, right, from the descriptive statistics to inferential statistics, both parametric as well as non-parametric. Let's come back to the data set and then we'll proceed with the statistical application part. Statistical interpretation part, right? Okay, so the various data set is already sent to you. If you are simultaneously practicing, you can practice along with me. So let me start with the descriptive statistics. Open the very first file, descriptive statistics. Okay, given any data set, first we have to understand the nature of the data set. Please visualize the data set. So if you come back to the variable view, these are the two variables listed here: gender, financial literacy. Correct now? So here in financial literacy is measured in a scale variable. Why it's on a scale variable? Can you see here? Nominal variable, ordinal variable, scale variable. Interval and ratio is collectively called as scale variable here. So scale variable is nothing but metric variable, right? So come back to the data view page. So all of you please understand the nature of the financial literacy. These are the financial literacy score of 20 respondents. Literacy score ranges from 1 to maximum is 12. So 1, 4, 3, 4, 5, 8, 9, and so on. So these are the data which is expressed in absolute numbers. Therefore, it falls under ratio data. Ratio in turn classified as the scale data or metric data. Then we have gender, which is 1, 2, 1, 2, and so on. Let's see what is this 1, 2, 2, and so on. 1 stand for male, 2 stand for female. Okay, 1 stand for male, 2 stand for female. I'll just demonstrate two important applications here. So one is label to values, value to labels. Can you see here? First respondent is male, the corresponding literacy score is 1. 8th respondent is female, the corresponding literacy score is 8. 13th respondent is female, the corresponding literacy score is 10, and so on. So I want to generate descriptive statistics for which variable now? So always descriptive statistics is employed for a ratio variable or scale variable or metric variable. For categorical variable, especially nominal variable, please mind you, we cannot perform the descriptive statistics. If we take descriptive statistics for gender, consider male we have coded as 1, female we have coded as 2. If the average mean value comes to 1.5, how do we interpret that 1.5? Right? It does not serve the purpose. It does not convey anything. Correct now? Therefore, we employ descriptive statistics always for a scale variable. Okay. How to employ the descriptive statistics? This is a syntax. So if you look at my screen, the syntax is displayed. Click on this analyze button and then check on this descriptive statistics. So we have got various functions here: frequency, distribution, descriptives, explore, crosstab, and so on. Since I'm performing descriptives, so I have to choose descriptives. Analyze descriptive statistics, descriptives. Press enter. So menu pop-ups here. So in this, let me choose the financial literacy score. This is the variable for which I want to apply descriptive statistics. So select this, put it on the other side, variable list. So for whichever the variable you have to perform descriptive statistics, you have to bring all such variable to the other side by using this arrow mark. And then click on this option button. So we have got various descriptive statistics parameters, right from the measures of central tendency, measures of dispersion, and measures of distribution, right? So measures of central tendency, we have got mean and sum, and then dispersion, standard deviation, variance, range, minimum, maximum, standard error, mean, and then distribution, kurtosis, and skewness. So whichever the statistical tool do we need to employ, you can employ the same here. For the timing, I'll restrict my discussion with mean and standard deviation. Okay, click continue, click OK button. So whenever we perform any syntax or any statistical tool, the same thing will be displayed in the output page of the statistical SPSS software. So this is the output page of the SPSS software. This is the output of the SPSS software. So all of you please go through this table now. So we have got the descriptive statistics table here. The number of cases, N stands for number of cases, number of respondents. There are 20 respondents here. The minimum literacy score is, financial literacy score is 1, and the maximum financial literacy score is 12. Mean, the average financial literacy score is 6. So how did we get this average? Sum of the observation by number of observations. And then standard deviation, so which is deviation from the arithmetic mean. Can you see here? Plus or minus, the standard deviation is 3.17. So means 6 plus 3.17 or 6 minus 3.17. That would be the range of the pattern, the data pattern, deviation from the arithmetic mean. Okay. One more important aspect here: when the data is normally distributed, we report what is called as mean and standard deviation. I repeat, whenever the data is normally distributed, statistics parameters are concerned, we report mean as well as standard deviation, mean plus or minus standard deviation. If the data is not normally distributed, please mind you, we cannot report the mean and standard deviation. We have to report what is called as median as well as quartile deviation. Median as well as quartile deviation. So median is nothing but the mid number. The quartile deviation is the difference between Q3 and Q1. Quartile deviation 3 and quartile deviation 1. So when the data is normally distributed, report mean and standard deviation. When the data is distribution free, report median and quartile deviation. So that is a basic understanding here as far as descriptive statistics is concerned. I'll just quickly show one more application in the statistical tool here before we proceed with inferential statistics. So we have got data here on two variables, literacy and gender. Let's consider I want to perform the descriptive statistics only for the male respondents. I want to find out the descriptive statistics of only male respondent. Then let me select the female respondent. So when we have the data entered in this pattern, how do we generate descriptive statistics only for the male respondent? Okay, there is an option called as select cases. In SPSS, there is an inbuilt function which is used in order to analyze the data segment wise. For example, if you have collected the data on different banks, public sector bank, private sector bank, and then foreign banks, we can analyze the data segment wise by employing this function called as select cases. How do we use that such function? So all of you please look at the screen now. Right. So here in the ribbon section, there's an icon called as select cases. Right. All of you please look at the screen. In the ribbon section, there is an icon called as select section from the last fourth button. So if you look at my mouse cursor here, it is showing select cases. Click on this icon, select cases. Now let's define the function. I want to find out only the male respondent descriptive statistics of financial literacy. So select the gender, that is a criteria. Here there's something called as if condition satisfied. Click on this radio button, if condition satisfied. Let us define the syntax now. Click on this if. Click on this if. Select this gender variable, put it in this numerical expression box. Select this gender variable, put it in a numerical expression box. Okay, so what I am trying to find out here, I want to generate descriptive statistics only for the male respondent, and you should be knowing the coding pattern. Male we have coded as 1, female we have coded as 2. So now I want to select only cases in which the gender is equal to 1. In which the gender is equal to 1. So I'll define the syntax, gender is equal to 1. Okay, what is 1? Male respondent. Click continue and then click OK button. Now the syntax is employed. We are in the output page. Come back to the data page. Come back to the data page. Look at the left hand side of the cases, the rows of the data page, right? The cases in the data page. 1 is a male respondent, not striked out. 2 is a female respondent, striked out. So wherever female is there, all such cases are not selected. Which can you see here? The third column. So only male cases are selected. Now we can go for employing descriptive statistics. How do we employ? The same syntax. Click on this analyze, check on this descriptives, and then choose descriptives. Already literacy score is there. Just click OK button. Just click OK button. Come back to the data view page. Come back to the data view page. Right. Okay. So we have got 11 cases here. What is this 11 cases? There were 20 cases in the previous example. Here only 11 cases. Means we have chosen only male respondents here. Right now. So out of this 11 respondent, the minimum literacy score is 1, maximum literacy score is 2, because both the scores are secured by male respondent. The average of the financial literacy score of male respondent is 5.55, and then standard deviation is 3.142. The deviation from the arithmetic mean, average value. Correct now. So this is how we perform the descriptive statistics only for the selected cases. The same thing holds good even for female respondent. For example, if you want to perform the descriptive statistics only for female respondent, let's change the syntax now. Select cases, if condition, so gender, if it is equal to 2, click continue and then click OK button. Come back to the data view page. Come back to the data view page. Come back to the data view page. Can you see here? Wherever male is there, all such cases are not selected because we have selected only gender if it is equal to 2. Let's employ the descriptive statistics now. Click on this analyze, check on this descriptive statistics. Literacy score is already taken here. Click OK button. Can you see here? Out of 20 respondent, 11 are male respondent, 9 are female respondent. The minimum score secured by male respondent is 1. The minimum score secured by female respondent is 2. Maximum score of male respondent is 12. The maximum score of female respondent is 11. The mean score of male respondent is 5.55. The mean score of female respondent is 6.16. So female respondents are more financially literate compared to male respondent. And then standard deviation is 3.142 here, 3.32. There's a greater variation in the financial literacy score of female respondents.
Sir, output page is not visible, sir.
I'm really sorry. Could you just check my now? So the minimum score is 11. Sorry, number of cases are 11, number of cases 9. The minimum score is 1 as far as male respondent. The minimum score is 2. The maximum score of male respondent is 12. The maximum score of female respondents is 11. The average score of male respondent 5.55. The female respondent 6.56. Female respondents are more financially literate compared to male respondent as per this data set. Standard deviation is 3.142. Here 3.32. So we conclude there's a greater variation because of higher standard deviation. There is a greater variation as far as female respondent financial literacy score is concerned. Right? So this is what is called as the financial literacy score. Okay. There's one query in the chat box by Mr. Pawan Kumar Guri. So I'll just throw a light here. What is missing cases? Okay. So let me unselect all the items. I'll just clear this option. Okay, now all the cases are selected. Consider we have collected data from the 20 respondent. Of this 20 respondent, consider one respondent financial literacy score is missing. That means to say, for certain questions he has answered, for certain questions he has not answered. Because of that, we cannot able to calculate the financial literacy score. Because of which we cannot able to calculate the financial literacy score. Okay, which is respondent number 7. Yes, correct now. Case number 7. Can I request all the participants to mute themselves. First. Yeah, thank you. Right. Just because one case is missing, can I completely eliminate that case? Does it make sense? Consider we have determined the sample size of 383 according to Krejcik and Morgan table. If I delete one cases, then it will come to 382. So once again, you have to go for data collection. It may not be the right procedure. What we do here, wherever the cases are missing, there's an option in spaces to impute certain values in the missing places. So what is that option? What is that function? The function is called as replace missing values. Okay. So let me show you that function. So if you look at my screen, so this is a data page. Click on this transform. In the transform icon, check on this replace missing values. Can you see here? Replace missing values. Check on this. Select financial literacy score because financial literacy score variable is missing. Select here. Okay. By default, the new name, what it has taken is financial literacy _1. Why? So in the earlier case, we have financial literacy here. The new name, what it captures is financial literacy score _1. Because if you enter financial literacy again, it will say duplication of variable. So you cannot enter the same variable more than once. Correct? Now, that's why it has taken _1. That's a new variable name. There are different methods to employ. Different methods are employed in order to impute the missing values. The different methods are series mean, mean of the nearby points, and then we have median of the nearby points, linear interpolation, linear trend at point. So these are the different methods available in order to impute the missing values. And we have literature support on each of this context. Okay, please do certain literature reading on this. When do we employ which technique? When the given variable is metric and the metric variable is missing, then we may employ either series mean or mean of nearby points. I repeat, so whenever the metric variable is missing for any particular cases, then employ either series mean or mean of nearby points. Both are well accepted, nothing wrong in either of the method. So both are standardly accepted methods in all the research cases. When the given variable is categorical in nature, what do you mean by categorical in nature? Consider we have got what is called as gender variable, male and female. If male and female are missing, we cannot impute mean value over there. What is supposed to be imputed then? The median value. Correct. Now, how do we employ this median value? We'll just see both the cases. Okay. So let me select the series mean first and then click OK. Click OK. Syntax is employed. So come back to the data view page. Can you see here? Previously, there was a missing case here. Now we have got 5.8 here, which is the mean value of the series. If you remember the very first case, when we employed the descriptive statistics for all the 20 variables, 20 cases, the mean value was 5.8. The same thing is appeared here. So let me increase the decimal point here. Yeah, the mean value is 5.84. The same thing as imputed in the missing place. This is called as series mean. Okay. Let me take one more case now. Okay, I'll just take off this now. If you employ the mean of nearby point, what happens? Let's see that now. So click on this transform and then check on this replace missing values. Really sorry, just a second. Okay, replace missing values. Just give me a second. Yeah, I'm sorry, there was some disturbance. Right. So how do we employ the mean of nearby points? Click on this transform button, check on this replace missing values. Replace missing values. Let me choose mean of nearby points. Mean of nearby points. Okay, what I'll do, just reset. I'll do from the beginning. Select the financial literacy score. _1 is already selected. Select mean of nearby points. The span of nearby points, let it be 2. What do you mean by 2? This is a missing place. 7th case is a missing place. 2 span of nearby points means previous 2 spans, 2 digits. 6th case and 5th case. The next 2 digits, that is 8th case and the 9th case, 8 and 7. So we are taking the average of the 2 spans. The preceding 2 spans, succeeding 2 spans. Once we feed the input, click on this change button. Then click OK. Now the syntax is successfully executed. Just a second. Okay. Is that my screen is visible now? Can somebody confirm?
Yes, sir. Yes, sir.
Okay,
Yes,
thank
sir.
you. Thank you.
Screen is
Okay. So now we have executed here. We have got the series mean value here. Sorry, mean of nearby points. Here there was a missing case. In place of missing, we have got 7 here. How did we get this 7? What we have done is mean of nearby points we have taken. So what is the previous 2 digits here? 5 plus 8 is equal to 13. Correct now? Next to 2 digits. 8 plus 7 is equal to how much? 8 plus 7 is equal to 15. 13 plus 15 is equal to 28. 28 is the sum of the observation. How many observations did we took? Previous 2 span, next to 2 span. So 2 spans. 2 plus 2 is equal to 4. 28 divided by 4, the mean of the nearby points is 7. The mean of the nearby point is 7. So this is how we go ahead with this replacing missing values for a metric variable. Consider one more example. I'll just quickly wind up before we take up the next concept. So in the gender, there is one missing value. So case number 6, they have not marked whether they are male or female. Maybe at the time of filling the questionnaire, they might not have seen this particular variable. Okay. But we have got the research variable. Financial literacy score is measured, right? Can we just eliminate this variable just because gender is not marked? It does not make sense, right? So what we can do, we can impute certain value in the missing place. How do we do that? Let's see now. Click on this transform. Check on this replace missing values. Okay. So now we have to impute gender missing value. Select gender, put it here. Okay. Gender underscore 1 is already taken. Please note, don't use series mean as well as mean of nearby points because it's a categorical variable. So what we're supposed to take is median of the nearby points. Select median of the nearby points. The span, let it be 2, or you can increase or to decrease the same, right? And then let me select all now. I'll just tell you what is this all. So span of nearby points, I've selected all. Click OK button. Any pending operations will be lost. Okay. So now the syntax is successfully executed. Just a second. Can you see now?
no, sir. Output page, sir.
Okay, I'm really sorry. There's some mistakes here.
Better you share the screen, sir.
Yes, 1 minute, sir. Yes, sir. Yes. Transform and then check on this replace missing values. Just reset the option. Select the gender variable, put it here. Select the median of the nearby points. Span of nearby points, you can choose number or all. Click OK button. Any pending operations will be lost. Click OK. Okay. So now gender, it has taken 1.42. Oh, I'm really sorry. I did not perform this. Really sorry. Okay. Transform and then check on this replace missing values. Replace missing values. Okay, let me reset all the options. So now we have to select gender, put it in the new variable. So now we have to select what is called as median of the nearby points. The span of nearby points, let it be 2. After feeding the input, please mind you, here, look at the syntax. What it has taken is series mean. Correct now? So we are not imputing the series mean. We are imputing what is called as median of the nearby points. How do we change it to median of the nearby points? Click on this change button. Previously, we did not perform this. Click on this change button. Now, can you see the syntax? We have taken a median of the gender variable. Click OK. Now the syntax is executed. Come back to the data page. Can you see here? Here, there was a missing value. In place of missing value, we have got median value of 1, which is male. The missing case gender was male, according to the data set, the median value. So what do we do here? We arrange the data in a chronological order, ascending order, and then we pick the mid number. So the mid number is male, which is 1. Right? So this is how we employ the replace missing value function in spaces. Okay, does it take only the average of only 2 succeeding and preceding cases? Because we have taken 2 spans, that's why it takes the average of 2 succeeding number and 2 preceding number. If you want 3 preceding number and 3 succeeding number, you can increase the span of control, the span of nearby points to 3, or span of nearby points to 4, and so on. That can be employed. Yeah. So I think now we are done with the basic application, which is descriptive statistics. we've just explored a few options in spaces, how to analyze the descriptive statistics for a segment, for a particular segment. Right. Okay. Let's come back to the data set. Having understood the very first aspect, descriptive statistics, let me open the data file. So we'll start from the inferential statistics. So inferential statistics, we'll proceed with the data analysis. So under that, the first one is to compare the test of proportions, different proportional category, proportions of categorical variables. So I've just compiled two data set here. One is chi-square test of association or independence. The another one is test goodness of fit test. Let me open the first file. Chi-square test association of or independence. I'll open this. Just a second, it's opening. Okay, so before that, let's understand the conceptual background of chi-square. Sorry. It takes few seconds to open the software. So yeah, so now we have got the data page here. Minimize the data page. Yeah. So look at this Word document now. Let's understand the conceptual background of chi-square test. Chi-square test can be employed to test the association between two variables, or to test the independence between two variables, two or more variables, or to test the goodness of fit between the categorical variables, right? So the nature of the variable should be categorical. So we must have categorical variable, then only we can perform chi-square analysis. Okay. The purpose is to check the association or independence or goodness of fit. So let's look at this data now and we'll understand what is the requirement. So we have got two variables here, age and investment avenue. So I want you to visualize the data before we employ any statistical tool. Age and investment avenue, look at this variable view. So the first variable is age and the second variable is investment avenue. And the values in the age, 18 to 28 is the first category, 29 to 38 is the second age bracket, 39 to 48, 49 to 58. Then in investment avenue, we have got equity, mutual funds, gold, real estate, fixed deposit, others. Okay. One is ordinal variable. Age is an ordinal variable, whereas this one, equity, mutual funds, gold, this is all just labels. It's a nominal variable. Ordinal variable also falls under categorical variable. Nominal variable also falls under categorical variable. The combination of ordinal and nominal is called as categorical. So let's consider we have to test the association between two variables. So we want to find out whether age and investment avenue are associated with each other or not associated with each other. Right? Associated with each other or not associated with each other. How to find out that? Right? Let's come back to the application. So as far as parametric application is concerned, we will be generating just frequency analysis in case of parametric application. Correct now? In case of non-parametric application, we'll be employing what is called as chi-square test. Chi-square test is a non-parametric application. Okay. First, come back to the data file. We'll just discuss how to generate the frequency table. So let us see how to generate the frequency table. Look at my screen. Click on this analyze button. Check on this descriptive statistics. Under descriptive statistics, the very first option is frequency analysis. Check on frequency analysis. Select both the variables. Bring it to the other side by clicking on this arrow mark. Make sure that display frequency table is checked on. This radio button is selected. Click OK button. So now we have got the output here. Look at the output. So there are about 100 cases, 100 respondent data are there. So out of this 100 respondent data, 62 falling in the age bracket of 18 to 28, 37 fall in the age bracket of 29 to 38. There's only one respondent whose age is 39 to 48 in that particular bracket. The percentage is 62, 37, 1. How did we get the 62? 62 divided by 100, 62%, 37 by 100, 37%, 1 by 100, 1%. Valid percentage and percentage is almost same here coincidentally because there are no missing cases. If there is any missing case, please note there will be difference between percentage and valid percentage column, definitely. Cumulative percentage is the added value of this percentage column. 62 plus 37 is equal to 99. 99 plus 1 is equal to 100. Similarly, out of 100 respondents, 66 respondents have chosen real estate as their investment avenue. 14 respondents have chosen fixed deposit, and there's only 3 respondents who have chosen gold as their investment avenue. So this is what is called as parametric application frequency analysis. Come back to the. Yes.
See, does the cumulative percent takes the accumulation of the valid percent or only percent?
Perfect. Cumulative percentage is the cumulative value of the valid percentage. Absolutely
Okay.
right. Not the percentage.
Okay. Since it is one and the same, it is showing same.
Cumulative percentage and valid percentage is same. Correct.
Only
Perfect.
valid percent is taken.
Definitely. Definitely.
Okay.
What happens now, ma'am, actually? So let me show you the data file. For example, if I just take off any one value here, then in that case, cumulative value and cumulative percentage and valid percentage and valid percentage will not be same.
Yes, sir.
Percentage will be considered for 100, whereas valid percentage will be considered only for 90 because one case is missing.
Yes, sir.
Right? So cumulative will be calculated based on the valid percentage, not based on the percentage.
Thank you, sir.
Thank you. Okay, and just what was the age variable we had here? I think 18 to 28. Okay. Having understood this particular case now, let's come back to the discussion now. So now let's see how to test the hypothesis by employing non-parametric test, that is chi-square test. So what will be the hypothesis here? Let me formulate the hypothesis quickly. So we say there is no association between age and investment avenue, and alternative hypothesis I'll state it as there is an association between age and investment avenue. Again, there will be many doubts here. Should we use only association or significant association? Or should we use only association or statistical association? All such concepts are perfectly all right. If at all, if you want to use, there is no statistical association between age and investment avenue, well, there's nothing wrong in that. If you want to use, there is no significant association between age and investment avenue, perfectly all right. Okay, so it does not make any impact on the output of the analysis. So it's only how you coin the terms in the hypothesis. And please mind you, whenever I have to use chi-square test, definitely the term association has to be mentioned in the hypothesis because chi-square term serves the purpose of association. How do we put it in the other way? For example, if it is test of independence, we say age is not dependent on investment avenue. Alternative, age is dependent on investment avenue. Right? In case of test of independence, we can formulate hypothesis like this. There is no dependency between age and investment avenue, or there is no, how do I put it? Age is not dependent on investment avenue. Alternative, I can say there is a dependency between age and investment avenue, or age is dependent on investment avenue. So that is how we coin the terms as far as chi-square hypothesis concept. So association term has to be included in the chi-square hypothesis. Okay. Right. Just a second. Come back to the data file now. Having formulated hypothesis, let's see how to employ chi-square test in Spaces software, right? So click on this analyze button, check on this descriptive statistics. You can make a note of the syntax, analyze descriptive statistics, and then choose cross tabulation. So syntax to employ chi-square test, analyze descriptive statistics, cross tabulation. Select age in the row cell, investment avenue in the column cell. It can be inversed also. Investment avenue, you can put it in row, and age you can put it in the column. So it will not have an impact on the results. Both are accepted. So once we feed the input, in the statistics icon, there is something called as chi-square. Click on the statistics icon button, check on this chi-square. Check on this chi-square. And then click continue, click OK button. Click continue, click OK button. Right? So let me come back to the output page. I'll copy these two tables and I'll put it in the Word document for interpretation purpose. Let me paste it here in the Word document for interpretation purpose. Interpretation purpose, let me paste it here. Yeah. So this is the output of the chi-square test. This is the output of the chi-square test. I want you to understand this numbers now, right? The first one talks about the cross tabulation between the two variables. The cross tabulation between age and investment avenue is denoted in the first table. 100 respondents are there. 63 respondents falls in the age bracket of 18 to 28. 36 respondent falls in the age bracket of 29 to 38. There's only one respondent whose age bracket is 39 to 48. Similarly, out of 100 respondents, 66 respondents have chosen real estate as their investment avenue. 14 respondents have fixed deposits, and so on. Correct now? Okay. So primarily we can say majority of the respondent falls in the age bracket of 18 to 28, which is younger generation. And then majority of the respondent have chosen real estate as the best source of investment avenue. That's a prima facie evident from this table. But what is important to us is the inferential statistics hypothesis test. There are many statistical analysis. We have got this in chi-square test table. But one which we are looking is here, chi-square test, which was developed by Carl Pearson. That's why it's called as Pearson chi-square test. So we have got this value, x square value, Pearson chi-square value, 39.66. Then we have got something called as degrees of freedom. So how much is the degrees of freedom here? Degrees of freedom is 10. And then we have significant value, which is 0.000. Okay, these are the three parameters which has to be reported when we perform the chi-square test, right? Pearson chi-square value, degrees of freedom, and then significant value. What is this Pearson chi-square value? Which is the summation of observed frequency minus expected frequency whole square by expected frequency, which we normally call it as x square value. So if you calculate manually for the same data set, we'll get x square value. How much? The x square value would be 39.667. Then what do we do in case of manual calculation? We compare this value with the table value, and then we take a call whether to accept or reject the null hypothesis. Degrees of freedom is equal to r minus 1 into c minus 1, row minus 1 into column minus 1. Look at this table now. So how many rows are there here? Excluding the labels, 1, 2, 3, 4, 5, 6. There are 6 columns, 3 rows. Correct now? That means to say there are 3 rows, 3 minus 1, and there are 6 columns, 6 minus 1. So 3 minus 1 is 2, 6 minus 1 is equal to 5, 5 multiplied by 2 is equal to 10. But the crucial aspect is significant value, which is called as p-value. So how do we interpret this p-value? P is the probability of accepting or rejecting null hypothesis. P is the probability of accepting or rejecting null hypothesis, right? So it's a percentage to an extent of which we accept the null hypothesis. It's a percentage to an extent of which we reject the null hypothesis. What is the decision rule here? Whenever p-value is less than or is equal to 0.05, right? Which is also called as alpha value. So what is this 0.05? Alpha value, the significant level. Then the decision rule is reject the null hypothesis. Reject the null hypothesis. Whenever the p-value is greater than 0.05, what is the decision rule? The decision rule is accept the null hypothesis. Accept the null hypothesis. When p-value is less than 0.05, reject the null hypothesis. P is greater than 0.05, accept the null hypothesis. In this case, what is the p-value? It is 0.000, which is less than 0.05. So what is the conclusion? We have to reject the null hypothesis. Let's go back to the reject null hypothesis now. What is the null hypothesis? We are saying that there is no association between age and investment avenue. This should be rejected now. When it is rejected, what is accepted? Alternative is accepted. We say there is an association between age and investment avenue. Okay, we conclude there is an association. Okay, very important. Age and investment avenue are dependent on each other. It is not independent of each other. It is dependent on each other. Okay. Normally, we being a scholars, we stop at this point. Okay. Once we find out significant result, we stop at that point. Any statistical tool for that matter, once the result found to be significant, we should not stop at this particular point. We have to explore further to what extent there is an association between two variables. When we are saying there is an association between age and investment avenue, to what extent there is an association, that is also has to be calculated, right? Association, the strength of the association has to be determined now. how to calculate the strength of the association. Okay, since we are saying there is an association, I'll just take another 10 minutes of your time. Please kindly bear with me. After completing this particular aspect, we can wind up the session. Okay, so when we are saying there is an association between two variables, let's find out the strength of the association. How do you find out the strength of the association? There are two statistical approaches to find out the strength of the association between two categorical variables. One is pi coefficient. Another one is Kramer's V coefficient. There are two statistical tools which are there in order to understand what is called as the strength of the association. The first one is called as pi coefficient. The second one is called as Kramer's V coefficient. Kramer's V coefficient. Pi coefficient, when to employ Kramer's V coefficient. Both the statistical tools serve the same purpose, finding an association. Then when do we employ pi coefficient and when do we employ this Kramer's V coefficient? Let's understand that now. Pi coefficient is basically employed when the order of matrix is 2 by 2. When the order of matrix is 2 by 2, we employ what is called as pi coefficient. We employ pi coefficient when the order of matrix is 2 by 2. If the order of matrix is not 2 by 2, if it is greater than 2 by 2, it could be any number. Just a second. When the order of matrix is not 2 by 2, if it is greater than 2 by 2, it could be 3 rows and 3 columns, 4 rows, 5 columns, 6 rows, 6 columns. If it is not 2 by 2, 2 rows and 2 columns, then we have to employ Kramer's V coefficient. So in case of pi coefficient, when we have 2 row and 2 column, proceed with pi coefficient. When we have Kramer's V coefficient, when we have to use Kramer's V coefficient, the order of matrix should not be 2 by 2, it should be greater than 2 by 2. Let's look at this one now. Could you tell me the order of matrix? Is it 2 by 2 or greater than 2 by 2? The order of matrix, is it 2 by 2 or greater than 2 by 2?
Greater than 2 by 2.
It's greater than 2 by 2. Perfect. Right? So what calls us to employ in this case here is a Kramer's V coefficient. Okay. Let's see how to employ the Kramer's V coefficient. Now we are in the data page. Okay. Click on this analyze button. Check on this descriptive statistics and then choose cross tabulation. The same syntax which we employed for chi-square. Analyze descriptive statistics, cross tabulation. So we have got this menu. Okay. In the statistics button, check on the statistics button. Can you see here? We have something called as pi and Kramer's V coefficient. Both the statistical tools are in the same place. Pi and Kramer's V coefficient. Okay. By default, we have to employ same both the statistical tool. Okay. So check on this pi and Kramer's V coefficient. Click continue. Click OK button. Click continue. Click OK button. Come back to the data view page. Sorry, output view page. So after chi-square results, we have got this pi and Kramer's V coefficient. I'll just copy this and paste it in the Word document for interpretation purpose. So if you look at my Word document now, so we have the results here. The result is here. Okay. Pi coefficient, Kramer's V coefficient. Anyway, since the order of matrix is not 2 by 2, we'll not be touching on this pi coefficient. Let's not discuss this pi coefficient. I'll just highlight with this red color. Right? Since the order of matrix is greater than 2 by 2, we have got 3 rows and 6 columns. Let's see how to report this Kramer's V coefficient. We have got Kramer's V coefficient value 0.445, 0.445, significant value 0.000. That means to say there is a significant association. Okay. How do we report this value? Okay. Whether it is a pi coefficient or Kramer's V coefficient, in both the cases, whenever the coefficient value, just a second, coefficient value whenever the coefficient value is greater than 0.10, or sorry, less than 0.10, we say there is a low strength of the association between two variables. If the coefficient value is greater than 0.10 but less than 0.20, then we say there is a moderate strength of the association between two variables. And the third classification, when the coefficient value, whether it could be pi or Kramer's p, please mind you. So when the coefficient value is greater than 0.20, greater than 2.0, less than 1, obviously it will be less than 1, then we say there is a high strength of the association between two variables. There is a high strength of the association between two variables. Let's find out now. 0.445, is it less than 0.10, or is it 0.10 to 0.20, or is it greater than 0.20? It's greater than 0.20. So that means to say, the conclusion is there is a high strength of association between,
Age and investment avenue.
yeah, association between age and investment avenue. Age and investment avenue. Right? So this is the conclusion. When we have this chi-square test, so whenever the value is significant, please mind you, we have to proceed with the post-hoc analysis. This also can be termed as post-hoc analysis. If there is an association, to what extent there is an association? Age is dependent on investment avenue to an extent of 44.5%. Both are associated with each other to an extent of 44.5%. That is the chi-square test. Okay. So I've taken 10 minutes of your extra time. Okay. Okay. Sir, Ashwat sir.
Yes, sir.
Dr. Ashwat sir. Sir, shall we wind up this session for today? Then we'll take
Yes,
up the.
yes, sir. If you want some more time, you can, sir.
It depends on the participant. I can proceed with this thing, sir. Can you just ask the participant?
Yes, participants, can we continue the session?
Yes, sir. We can continue, sir.
Yes, sir. Yes, sir. We can continue.
Please
So
continue,
next,
sir.
how much time?
Okay. Then I'll do one thing. I'll just perform one more chi-square test, goodness of fitness. Then we'll wind up.
Actually, you have not taken any breaks, sir.
No issue, sir. No issue, sir. No. Thank you, sir. Right. So now, having understood the test of association and the test of independence, so let me close this file, the spaces file. I'll just take another file now, so which is used for goodness of fit index. All these files have been shared to you. So at any point in time, you can practice this. You can look at that live stream video and then you can practice it. So let me choose a second file, chi-square test goodness of fit. So I'll open the second spaces file, chi-square test goodness of fit test. Goodness of fit test. So on each of the parametric application, non-parametric application have compiled a file. So we'll complete all these files within tomorrow. So by tomorrow 12, I think we can able to complete. We'll see. Okay. So now let's understand what is the goodness of fit indices or goodness of fit test. Okay, sorry, goodness of fit index. So there is a single variable which is called as investment avenue, Look at this options in the investment avenue. So we have got equity, mutual funds, gold, real estate, fixed deposit, others. It's a nominal variable. Okay. So when we are measuring this variable, that is investment avenue, let's consider we want to find out whether respondent chooses all these investment avenues proportionately or disproportionately. Or in simple terms, let me put it this way. Whether there is an equal chance of selecting all this investment or whether there is not equal chance. Whether investors prefer all the 6 investment avenue equally or whether don't prefer this investment avenue equally. So whether there is an equal weightage or not. Whether there is an equal probability of selecting or not. So there we use something called as goodness of fit test. Goodness of fit test. So let me go back to this word application. I'll just formulate hypothesis for this goodness of fit indices, fit test now. Goodness of fit test. So how do we formulate hypothesis in this case? We have a single variable which is called as investment avenue. Okay. So we say null hypothesis as there is no difference. There is no difference in the probability And please mind you, I'm not using the term association because association independence we have discussed in the previous case. Now we are checking the proportion in difference. Okay, there is no difference in the probability of the various investment avenue. Probability of selecting the various investment avenue and alternative. I'll just put it as there is a difference in the probability of selecting the various investment avenue. In simple terms, I'm just putting in the null hypothesis saying that all the 6 investment avenues will be selected by the respondents equally. Correct? Now 1 divided by 6, it will be like 16.67%. In the alternative hypothesis, I'm saying that the investors choose this investment avenue not equally. So some may prefer more real estate, some may prefer less gold, and so on. So that is what I'm basically trying to test here. There is no difference in the probability means investors choose all the investment avenue in the same proportion. There is a difference means investor chooses investment avenue on different proportions. The weightage will not be same for different investment avenue. Okay, so it's investment avenues. So okay, so for that, let's employ what is called as the chi-square goodness of fit test. How to employ chi-square goodness of fit test here? Click on this analyze button. So it's a non-parametric test, right? Click on this analyze button, select non-parametric test. This is a syntax. So all of you click, look at the screen. Analyze non-parametric test. Analyze non-parametric test. Under that legacy dialogues, choose legacy dialogues. In legacy dialogues, the very first option is chi-square. Analyze non-parametric legacy dialogues chi-square. Select this. Select this investment variable, put it in the test variable cell. Select this investment variable, put it in the test variable cell. Okay, so in the expected value, we are saying that all the investment avenues are selected equally. Can you see here? All categorical variable will have equal proportions. What is that equal proportion? There are 6 investment avenue. That means to say the probability of selecting gold will be 1 by 6, which will be 0.16 or 16.67%. The probability of selecting real estate investment will be 1 by 6, 16.67%, and so on. So all categorical variables having equal weightage. Just click OK button. Just click OK button. So now we have got the results here. So let me copy this output in the Word document, and then we'll see how to interpret the results. Right. So look at this number now. Out of 100 respondents, equity is chosen by 7, but the expected count is 16.7. Correct. Now, how did we get this 16.7? It will be like 1 divided by 6. There are 6 investment avenue. So chance of getting, the probability of selecting equity avenue will be 1 by 6, 16.67. So the residual value is minus 9.7. Mutual funds was selected by 5 respondents. The expected count is 16.7. The difference is minus 11.7. Gold is chosen by 3. By expected count is 16.7. Real estate is chosen by 66. The expected count was 16.7, and so on. But what is important to us is the chi-square value, degrees of freedom, and also the significant value. So chi-square value is 179.66. 179.60. How did we get this now? Observed frequency minus expected frequency whole square by expected frequency. When you take a sum of it, we get just 179.67. Degrees of freedom is 5. So in this case, degrees of freedom, how do we get this degrees of freedom? N minus 1. N is equal to 6 cases, minus 1 is equal to 5 cases. Okay. And then significant value is 0.00. How do we take a decision of, since p value is 0.000, which is less than the alpha value, which is 0.05. Correct now? So what is the conclusion now? The conclusion is reject the null hypothesis. Reject the null hypothesis. We have to reject the null hypothesis. What is our null hypothesis here? We say there is no difference in the probability of selecting the various investment avenue. It is rejected. We conclude that the probability is not same. There is a significant difference in the probability of selecting various investment avenue. So the probability is not same, so it's different. Here we need not to perform any post hoc analysis like what is called as Kramer's P or pi coefficient. One can easily say the equal chance is 16.67%, or so approximately 16.7%, right? But the selected respondent count is only 7. So the difference is so and so. You can report the same thing in the analysis part. To that extent, there is a difference. To what extent there is a difference here? When we are saying that there is a difference in the probability means, can you see here? 16.7 is a count, but the actual count is 7. The difference is minus 0.97, minus 9.7. In the second case, 16.7 is the expected count. That's the equal probability. When we are concluding there is a difference, so 5 is the actual count. 5 minus 16.7 minus 11.7. To that extent, there is a difference. Okay. This is about the chi-square goodness of fit indices. Chi-square goodness of fit indices. Yeah. I think we can wind up the session now. Sir, Dr. Ashwath sir.
Yes, sir. Yes, sir.
Shall we wind up the session and then take up the remaining concept in the subsequent this thing?
Yes, sir. Yes, sir. Tomorrow we can continue, sir.
Right.
Sir, like any questions from the participants, sir?
Yeah, I forgot to ask. I'm really sorry. So if any queries or questions from your end, please put it in the chat box, or you can unmute yourself and then proceed with the questions. Yeah. Okay, there's a question regarding send feedback links, sir. Okay. Yes, madam.
Yes, sir. We'll send you, sir.
Yes, sir. Yes, sir. Yes, madam.
Santanu, sir.
From Kanyakumari.
Yes, ma'am.
Sir, I am at education field.
Okay.
So, sir, can you tell me how far I can use this goodness of fit my using the psychological variable and in education research?
It's not about psychological variable. Any variable for that matter, if it is expressed in categorical form, categorical nature, depending on the context, we can use this cases. For example, if you could let me know any one particular variable. Okay, consider male and female. Okay, so we have got 10 respondents, ma'am, male and female. Now we want to find out whether the probability of male and female is equal or not equal. Probability of male and female is equal or not equal. Okay, so male and female is a categorical variable. Proceed with the goodness of fit indices, that is chi-square test. Check whether this distribution, data distribution, is having equal weightage or not. Whether male and female are equally distributed or not equally distributed. Okay, so depending on the context, you can use this goodness of fit indices for fit test, ma'am.
Okay, sir. Okay, sir. Thank you, sir.
Thank you. Okay, so there are certain questions in the chat box. I'll just quickly take up. If n value is different from the question to another question, okay. If n value is different from question to another question, then which test is the best, sir? Mr. Pavan Kumar, I did not get your question exactly, precisely. If n value is...
Sir, actually...
Yeah, yes, sir. Yes,
okay,
sir.
I will explain you. There is a respondent who didn't answer, like... there is a question in my thesis, like what is the satisfaction level of Facebook towards educational practices?
Okay.
What happens? Some of the respondents not responded for that question, but they responded for the LinkedIn question.
Okay.
The same question is asked on LinkedIn.
Okay, right.
Then there is while applying the test for hypothesis, how can I apply any test for that?
The n value will vary.
Or how can I interpret that?
Got your point, sir. Got your point. So n value for LinkedIn questions will be different from n value for Facebook question. Absolutely right. So that is what we do in the data cleaning process, sir, actually. Once we enter the data in spaces, there are 3 stages involved in the data cleaning process. One is we identify the missing value and we bring in certain value in the missing place. That is step number 1 in the data screening or data cleaning. Step number 2 is we identify the outliers and then remove the outliers from the data set. If there are any outliers in the data set, we identify such outliers and then we correct such outliers. That is step number 2. Step number 3 is we identify the unengaged responses and then we correct the unengaged responses.
Okay.
Only after this 3 exhaustive steps, we proceed with the data analysis. So when you do this data cleaning process step in your data, definitely that issue will be taken care, sir. Wherever the missing values are in the Facebook question, for the Facebook question, at least out of 100 respondent, if 10 respondent have not answered, remaining 90 respondent would have answered that question. Correct now.
Yes.
What we do is we take the mean value of such 90 respondent and we impute in the missing place for the 10 respondent. So that in both the cases, Facebook question also n is equal to 100. In LinkedIn question also n is equal to 100. You can proceed with the analysis.
Okay, but what happens if they haven't answered? That means we only answered that. Na, the respondent is not willing, or he don't know that, like anything. He don't want to answer, or what?
If for a particular question, if all the respondent chooses not to answer, definitely you have to re-look into that particular question, sir. There will be some kind of probably privacy matters, or the respondent may hesitate to answer such questions. We may have to re-look into that particular question and then reframe that particular question. It cannot be like for a particular question, all the 100 respondent cannot, is not willing to answer. I think I don't, probably there could be some issues involved, the privacy issues, or the respondent may hesitate to answer such questions. Some or the other way, something will be there in that question. So we can just reformulate that question and then proceed with the data analysis.
Okay, sir. Thank you, sir. Thank you.
All the Excel sheet, Word document, whatever discussed today, definitely it will be shared to you. So what is the basic difference between parametric application and non-parametric application? That is what. The basic difference, of course, in academics books, we get many differences, such as normality, homogeneity, and then linearity, multicollinearity, and so on. So parametric is nothing but we presume certain assumptions with respect to a population, whereas such assumptions need not to be satisfied as far as non-parametric application. The basic understanding of parametric, anything which is measurable is a parametric. Anything which is not, which cannot be measurable is a non-parametric. That's a basic difference, what I can say. Okay, I think, right, what is the basic difference is over. Worksheet will be shared to you. Definitely, yeah. Any other questions, please unmute yourself, then please, we can proceed with the discussion. Any other questions? Or anything you would like to add on to the discussion, what we had today? You're always, it's most welcome.
Yes, sir. Sir, we'll take questions, and if there are some more questions from the participants, we'll take the questions on tomorrow, sir.
Right, definitely.
Is there any announcement for tomorrow?
Tomorrow, yes, I think if you're simultaneously practicing along with me, please, I request all of you to download the data set which you have sent to your registered mail ID and then put it in the desktop. That is one thing. And please try to log in from the mobile so that from the laptop you can simultaneously practice along with me. Please note, Spaces, it's all about practice. Those are we are practicing for the first time. Probably the software may not be so much familiar to us. When we practice repetitively, then we'll be familiar with the software. Any issues we can able to address in the software, right? Okay. So the one thing is, please download the software, and then tomorrow's session will simultaneously practice all the concepts, whatever you have discussed, right? From one t-test family, ANOVA family, correlation, regression, and so on. And I request all the participants to join exactly sharp by 10 o'clock so that we'll effectively utilize the time, 2 hours time, right? So if any additional time is required, I request all of you to spare some time so that we'll complete all the concepts, whatever is assigned to me. So due to time constraint, we may restrict certain concepts, but let's see, we'll try to complete all the concepts. Okay, that's all, sir. Dr. Ashwath Kumar, sir.
Thank you, sir.
Yes, sir.
No participants are asking any questions. So thank you, sir. On behalf of Seshadripuram Research Foundation and Seshadripuram First Aid College, PG Department of Commerce and Management, and Indian Council for Cultural Relations and Karnataka Science and Technology Academy for being a resource person for today and also for tomorrow also. Yes, sir. We'll meet you on tomorrow, sir.
Right, sir. Thank you. Thank you, sir.
Sorry for not giving a break, sir.
No issue, sir. No issue, sir. Need not be, sir. Thank you, sir. Thank you.
Yes, sir. Welcome, sir. Thank you, participants. Please join on tomorrow by 10 o'clock, exactly by 10. Thank you all. Have a nice day.
Oh,
Santanu sir.
ശരി.
Santanu sir.
പുള്ളിപ്പോ ഇവിടെ ഉണ്ടോ? എല്ലാ തിങ്കൾ ചൊവ്വ വ്യാഴാഴ്ച വൈകിട്ട് വരും, പിന്നെ തിങ്കളാഴ്ച പോകും. അവിടെ പേഷ്യൻസ് ഒക്കെ കുറവാണ് ഈ പറഞ്ഞ ഇതുപോലത്തെ അസുഖം.
Yes sir. Santanu sir. Santanu sir. Are you there? Thank you all participants. You can leave the meeting. There is some technical issue to end the session. You can leave the meeting on yourself.
Ashwin sir. Ashwin sir.
Yes.
Hello.
Sir.
Sir, feedback link, sir. Feedback.
I think already it's sent, sir. It is sent in the chat box.
Okay, sir.
Again, I'm sending.
Okay, sir. Send me, please.
And participants can leave the meeting. There are some technical issues, so we can't end the session.
It's okay, sir. It's okay.
Yes, sir.
Send the feedback link, sir.
Yeah, I've sent it, sir.
Okay.
Ashwat sir.
Sir. Sir, we need to end the session, sir. Actually, our session is done.
Close marbodu?
Yes, sir. Yes, sir. Yes, sir.
Thank you.
Yes, sir. Thank you, sir. Thank you, sir.